How we doing? It's Thursday night. Feels like Friday night already, doesn't it? Well, it does to me in a way. Uh, Glad to see everyone tonight. Hope you're doing well here in the Land Timber Stream, day 433. And yeah, I've misplaced my shades. I don't know where they are. So, but the lighting's pretty decent now with this ring light, so we're all good. Yeah, we're discussing. Let's discuss some more QoS. Class-based shaping with CBWFQ. This is a lab. We'll try to do it tonight. As a matter of fact, let me fire up the... Tonight we're going to go with the Azure lab here. So let's get that kick-started. Launch that script. And in the meantime, just do a little bit of vlogging here. Today was a catch-up day on flashcards. Man. Catching up is a beast. It's tough, but it's been good. I actually added a flashcard or two today based on some reading in the INE workbook. So we're down in the, well, to review 74, I guess that's the total, including new and learning. Not 100% sure. But yeah, we're getting it down in at least the somewhat manageable numbers. I think I already did this one day. The IPv6 universal unique local address range. There's a quick. We should do a couple flashcards just to start out the stream when I get really behind. Do you know the range? So that is going to be, let's say the first address would be F. Sorry. Yeah, FC007. That's the subnet or the network range. And I believe that, so that will go to FC to 0 through FDFF. I believe that's right. Yeah, unique local. It used to be two different groups. I think it used to be org local and site local and org local. But now I think it's just unique local address range. Let's see. Hey, I got it. Yeah. I had to think about that for a second, but yeah. So here's the card though. It has a start and the end range like we're used to seeing with IPv4. I liked it. I've done that on some of these cards to help me sort of visualize like the whole range. And then I even put the bits here just to see why sometimes is it FC00 to FD. Well, that's because it falls within this nibble. 7 is a very odd. I wonder why they selected that. But anyway. So that's a good. Here's another one while our lab is booting up here. Disables unicast IPv4 address family in BGP. I struggle to sometimes remember this command. The format of it. I want to be able to type it without having to use context-sensitive help. So if you're doing VPN v4, right? And I think it is no BGP IPv4 default. Oh no, it's unicast. No BGP IPv4 unicast. I want to say there's a hyphen here. Ah, see, I got it wrong. It's no BGP default. I'm trying to remember that. No BGP default IPv4 unicast. And there's a stupid hyphen there for some reason. Anyway, so yeah, just a couple. I'll put a good on that because I had it in concept, but I have a lot of cards to catch up on. Also, while that lab is booting up, let me go ahead and get the requirements going here. Let's get our notepad running for this lab. Requirements. Standard disclaimer, I don't show it on stream for obvious reasons. This is not my lab. This is from the INE workbook. There are links on my page on how to obtain this workbook, how to purchase it yourself. If you'd like to see the workbook itself, the answer key, the notes, all the good stuff. But here are requirements for this lab. So this is going to be on R6. We're going to do shaping to limit sending rate on V146 to 384K. I'm all capping you, sorry. 32K of priority for small packets with L3 size of 60 bytes, aka voice, using a 4,000 byte burst value. Okay, we'll see if we can figure out these numbers. We want HTTP traffic to get 256K of the shaper's bandwidth. Unclassified traffic should receive fair queue treatment. A lot of these, to be honest, I've been doing them in Notepad for no particular reason, just because I have felt pretty confident on some of these. So we're going to have a child policy and a parent policy because we're dealing with sub interfaces. So we know that already. So we're going to have a policy map. V14, let's see, policy, V146 out, child, and we're going to do class, and this is where I sometimes start at the bottom, which is okay. Class map, and we have a couple of classes here. We have a default class, we have a class, we want to match a certain size. So let's say class voice match. Now are these going to be, okay, there goes the VM firing up. Let's see, match, and these will be what type of packets? Layer 3 size. So there will be IP packets. Match IP packet min 60, max 60. I think that's the command. And then we're going to class map class HTTP. Now, if this is like the other labs, we'll just say match protocol HTTP. We'll do that. We use inbar because other than that, we don't really have any indication of what they're looking for here. So, all right. So then we'll do the policy map, policy V146 out. Actually, this will go last, I think. So the class voice is going to be priority queue, priority 32. Now, we have to be careful with the computations here. Now, this is shaping, so this is purely in bits, not bytes. So I need to check if this is bits or bytes, because bytes is what we're looking for here on matching on the classification. So do priority 32. Oh, but we want to have a burst value for this. Okay, so we need to do a formula here. I'm going to need the parser for that because I have not actually done that before. Like, how do we set a burst size for just one queue? I don't know that you can do that. Maybe you can. Find out. All right, so we got our lab loaded up here. We're going to go to INE. And we're going to go to QoS. Nope, don't want to move it. QoS initial. Open. And we'll just do router like 6 and 4. I do need to work on transferring my license, my EvenG Pro license. It's not officially supported yet. There are some issues. But I think I may venture just to help out one of the developers that's in our Discord. By the way, if you're not in our Discord channel, folks, you're missing out. Lots of good stuff, good conversations in there. Guarantee. Okay, so yeah, we'll just move on from that. We'll just say priority 32 for now. We'll come back to this. This is the crux of this lab right here, I think. Because I know you can configure burst on the shaper. Unless that's talking about the policer in the priority queue. Crisco 762, I think you would have to do a policer to burst rather than just the priority. That's what I'm thinking also, Crisco, but how do you configure, because priority comes, okay, so yeah, priority comes with a default of 10%. I remember that from flashcards. So it has a built-in policer so that it just doesn't take all the packets. But you can change the default value of that, and that's probably what it's asking. So yeah, it's looking like it's asking us to change. So how much percent is 4,000 bytes? That's what we have to figure out, right? And a policer does use bytes. So if we think about how much bandwidth are we going to get? We're going to get 32 kilobits per second. So if we take 1 second, what is our committed burst? Yeah, but the policer is not calculated the same as the shaper. Let's look in our documentation here and let's see how we configure the built-in policer on the LLQ, the low latency queue. Yeah, this is true. I have not done this yet, so this is new lab area for me. We could go config guide here. Let's go config guide, quality of service. And we're going to want to look at LLQ. Classification. Policing and shaping. All right. And this is actually under shaping. No. We probably want to go to classification, right? No, that's just marking. Maybe it's under here. No. Bandwidth estimation. That's pretty cool. I actually discovered that the other day. Where is LLQ covered in the Cisco documentation? Congestion management? Okay. Excess traffic is dropped, right? By default. Bandwidth calculations and LQ with priority percentage. So do we have to use percentage? Yeah, I want to see, okay, configuring priority. That's the old PQ. Be nice just to have something on priority queuing, because the article we were looking at was priority percent. Yeah, it's the Cisco docs are an exercise of frustration. Yeah, go to your main configuration guide on queuing and tell me about RSVP. That's going to do me a lot of good. Okay, guarantee priority command. If no access to priority traffic will be constrained to configure rate via packet drops. Yeah, when a class is constrained to its individual rate, the traffic is permitted a certain amount of burstiness. The amount of burst is controlled by the optional burst parameter in the priority command. There we go. That's what I need. This burstiness cannot be specified when specifying a priority queue based on a percentage, right? Yeah, I didn't think we could use the percent command here. This has to be the bandwidth. The default burst value is 200 milliseconds of traffic. The burst parameter specifies in bytes the amount of traffic allowed to pass the token bucket as a one-time burst. Okay, so this might be really easy. It might just be, and I don't know if you type burst here, because while it would be cool for them to proffer an explanation with an example, of course that would be too easy. They're not going to do that here. So you'll have to go to the command reference to find out how to do that. Good TIO. Oh, cool. Don't need policer to do burst. Yeah. So, okay, fine. We will go to the command reference. Because we abandon all claims to user friendliness here. 15.6 master index. And we want the priority command. Okay, so burst, bandwidth, and then burst. So the burst here, that would be 50K burst of 60 bytes. Easy enough, easy peasy. So this is going to be 32 burst. That's a lot of burst. Okay, so that handles that. Class voice, class HTTP. He will get bandwidth 256. I think it's just bandwidth, yeah. And then we'll do class default class FairQ. Which is a nice, this is a pretty good looking policy. Like I might use this. It wouldn't be 384. And it might not just be HTTP, right? But this is, so what we're doing here is what do you typically use your LLQ for? Generally you get one low latency queue on a lot of platforms, not all. But what do you want to use that for? Well, you want to use that for voice. Your low latency traffic, latency intolerant traffic. And, you know, you give it, and it's small, it's 32K. And then you apparently have a lot of web browsing, right? Or web traffic, whatever the case may be. So you've got this other class with a bandwidth guarantee when there is congestion. And then you have weighted fair queuing, good old faithful weighted fair queuing, which does a great job, does flow base up to 4,096 individual queues. And it has its own drop policies, right? And is weighted. So this is a nice, some of these others are kind of, these are weird, but this is like a pretty practical looking. And this could be like a remote site out in the middle of nowhere that only has, you know, ISDN or something. I don't know. All right, so then what we would do is policy map, policy, and it would be class default class, and it would be shape average 384 service policy v146 out child. And then we go to our interface, jazz01146, service policy output, policy v146 out. So let's put it in the router and see how we did here. We only had to use, well, we'll see if this is right. I'm not sure about that. I think that's right. Let me close this. And we'll go into router 6 here. And I'm going to type this out just for practice. I'm not going to attempt to copy paste here. We're just going to practice here. So class, map, class. I like these. We don't have to create access lists. Match IP No, yeah, man. Match packet. Okay. Match packet length. Min 60, max 60. I have a flashcard about this. Command. Okay, match packet length. And when it says packet, it means IP layer 3, layer 3 Ethernet. Okay. And class map match protocol HTTP. That turns on inbar. And it's like, whoa, I need more CPU for that. Then policy map, policy v146 out child, class voice, priority 32, first. Oh yeah, I don't specify the word burst. 4,000 bytes. Class HTTP, bandwidth. I could do this 256. I think. Nope. And then class default. I always do that backwards. Bear Q. So policy map v146 out parent. A class default. Shape average. Okay, this is where I can do 384K. And then service policy v146 out child. Interface J01146. Service policy output. Uh-oh, insufficient bandwidth for the bandwidth guarantee. So, Tiny getting sneaky on us here. How is that not enough? Because, okay, all right. The default class default automatically reserves, is it 20%? You can change that. But let's see what that is. 384.123. So that would be 38K. No, that would be 76K for class default is reserved. Then you have 32K for priority queue. We're oversubscribed, huh? So that's 108. You take 384 minus 108, and that means you need 276. And it told us we need to reserve 2. So that should be enough. Whoa, it's my stomach. So why is that not enough? Insufficient bandwidth, 256K. Yeah, because this is done last. So basically, when it calculates, what you want to do is you take the priority queue, subtract that. You subtract the reserved bandwidth for the default class, and then you subtract any other bandwidth reservations that you made. So that should be, we should be okay there. 384.000 minus 32 me do this again. Minus 32 minus 20%. So I did my math wrong. 4, 1, 3 times. Yeah, 76800 minus 256123. So let's just do 3840 minus 320 minus 768 minus 2560. That still leaves bandwidth, so I don't know why. Did I put the wrong thing? Let me see. Show policy map. Oh, okay. This should be 256. This is a typo. That's okay. It made us rethink how we calculate. It made us go through the process of checking our bandwidth calculations here. Bandwidth. Class map. Class HTTP. Class map. Bandwidth. Is it going to actually make me type again? Match protocol? That, I'm sorry, but that is... All right, what is going on here? Show run. Why can't I type bandwidth? Okay, what? Oh, that's under policy. That's why. Okay, match protocol. That's me. So no, it says, I know they don't use consistent units. They really don't. That's policy B146 out child class. Yeah, so under priority, first of all, it does not make you type the command. So we're doing a low LLQ, low latency queue. We're typing priority. Why would you not, if you're the people who makes the parser, why would you not do priority bandwidth and then a number which would be a consistent way to specify the bandwidth, like K, like allow me to use K or allow me to use whatever. Whereas I'm defining a CBWFQ, no, you make me type the word bandwidth and you make me type out all the digits of, you make me type it out in bits. But I'm not allowed to use a K. But when I use the shape command, I'm allowed to use a K. Yeah, it's just so inconsistent. Yeah, I have to type kilo bits. All right, this is my next rant, Twitter rant here. The other thing is really kilobits is misspelled. I'm sorry, but that's incorrect grammar. What the heck? Bandwidth 256. Show policy map. So this is the other thing. You're showing me the CIR here. But let's not show you the way we showed it to you up here. No. We're going to do bits per second here. Yeah, inconsistencies are... There's an interesting Network Collective podcast episode that talks about the parser police that used to exist inside Cisco. I need to check that one out, Crisco762. One day when I get into a rage, I probably need to go going to blame them. Apparently the parser police were not doing much policing because they, I don't know. I got to check out the episode for sure. They have some great episodes on Network Collective, folks. If you're not signed up to their, I haven't been listening to it just because I've been so, nose to the grind. But yeah. All right, so service policy output. Policy V146 out parent. I'm really looking forward to seeing those folks too. I got to meet at Cisco Live last year. It was my first. And I got to meet several of them. In fact, I sat down with them for a while. That's when I met Russ White as well. And they're such cool people. And yeah, we actually talked about the Network Collective. And what they had done is they said, fans of Network Collective can meet us in the cafeteria at such and such time. So me and my friend Tony, we went and met with them. And it's funny, Tony got into a situation where he asked a very technical question of Russ White, and Russ White ended up pulling up on his laptop. He's like, well, let me check. This is about EIGRP hashing. Let me pull up the source code for EIGRP. I've got it here on my laptop. Or something to that effect. And we were like, whoa, these are heavy hitters over here. But they were so cool about it, That's what I love about this community. It's great. All right, so this looks good now. It allowed me to add the policy. So let's do show policy map interface J01146. And we go to output, we go to class default. Yeah, that's awesome. That is great. It is a great group. It really is. We're all kind of sitting down eating lunch, and they're just really cool. They actually gave me once a day, they're awarding free community memberships to the Network Collective. So I actually got awarded one day a community membership, so that gave me access to their Slack channel, which unfortunately I haven't had enough time to go check out as much as I would like to, but I have interacted in there a number of times. The community membership does not give you access to the regular member content. They have some regular member content now that you can pay to become a regular member and get, which I may end up doing. All right, so we have class default, and then we have our shape rate. Good. Then we have a service policy under that. And priority class is queuing. Class voice, 18 packets. Match packet length of 60, basically. Priority 32K, burst bytes 4,000. Match protocol HTTP, bandwidth 256, queue limit 64 packets, and then we have class default. So, yeah, I'm going to go ahead and take a look now at the answer and see if I got it right. Match packet length. Well, I'm glad I have a flashcard for that because I'm going to need to repeat that. And they did do an access list. I don't know why. I don't know if I agree with that completely. I guess people these days say HTTP traffic. What they really mean, right, in modern day happenstance, is they're really talking about HTTPS traffic, TLS, because the majority of traffic now is HTTPS. Even we do, even at our job, that's kind of a security requirement, even internally. Server to server traffic that is HTTP is really running over port 443, right? But the lab workbook here has an IP access list. Permit TCP any equals 80 any. And in modern day network, you would not do that. Anyway, I realize that this portion of the workbook is kind of old, but anyway. Class map HTTP match access group name, yep. Class boys party 324000, good. So yeah, we figured it out. Shape average now. They have done something different here. I want to find out why. This says shape average 7680. I don't know what this is. Probably some INE sneakiness. Let's see. So it starts out with an explanation telling me like the way you used to do it. Don't care about that. I'm new to QoS. You don't have to explain that. And it actually only serves to kind of confuse me. Like some of these discussion, a lot of them start out talking about priority queue, PQ, and CQ or something like that. Like pre-MQC. Don't care. Don't need to explain any of that to me. It's only going to confuse me. Anyway, when you nest a configuration inside a shaper, note the priority queue bandwidth 32. This assumes they're using G.729 plus 18 bytes overhead for an Ethernet header. Right, we've done that in another lab. And of course, the priority bandwidth command does take in layer 2 into account. Yes, we know that. It does not explain this is frustrating. So they put shape average 38400 7680. Every other lab in here, it does not, it just says shape average. It doesn't put a figure here. So I appreciate that they're expanding our horizons. They put a figure here in this lab, but there's absolutely no explanation of why they did that. You got me. I don't get it. What is the committed burst here is 1536. I guess what I could say, maybe they just want me to figure this out, but obviously they're allowing a burst on the priority queue of 4,000 bytes. This is more than that. You got me. Thanks, Heine. All right. Anyway, we're going to mark this one done. This one looks good. And on a Thursday night, I think that's going to wrap it up for me. I've got to do some prep for tomorrow. I did not make the gym this morning because I worked late on a change last night and ended up staying up kind of late. But tomorrow I hope to hit the gym. And there are, so the remaining labs, as you can see, this one did not really take all that long, even though it introduced something new. But we've got hierarchical policers, 2-rate 3-color, percent-based policing. This will be new, QS pre-classify, which you want to do for tunneling. That's a tunneling feature. So cool. So we may be tomorrow. I don't stream. It's Friday. I have the day off from streaming, but Saturday I feel like I should be able to wrap this up. QoS. Then just kind of taking a look down the road here. Security. Quite a few labs here. How many labs is this in security? QS has been interesting in that it's been like concepts to learn. Security for me is just kind of like a lot of memorization. I know how these features work pretty much. But we'll find value in them and learn some new things. And of course, get faster and faster at labbing this stuff. That's the goal. There are 25 labs in security. So, hey, who knows? We might get those done in May. That would be kind of a little bit of a goal. General goal. If we can get these done in May, and then we can move on to similar kind of thing, system management. Oh, I forgot about IP services. That's right. So May, security, June, Cisco Live, but system management. July, IP services, we start hitting foundation and advanced. We start doing like big labs in August, looks like. Which means lab attempt is looking more like November than September. Yeah, QoS is taking up a lot of time, but that's okay. Good stuff. All right, that's going to wrap it up, folks. Hope this Friday Eve, right? It's Thursday night. Hope everyone has a great Friday tomorrow. And you know, let's get ready for the weekend. I don't know if you're labbing or what you got going on, but if you are, I wish you good bits, and we'll see you here on Saturday here on the Land Tamer stream. Thanks. Have a great night, and see you all again very soon.